Hi everybody, we're going to be talking about sequences and functions today, specifically patterns that grow. So we're going to remind ourselves of stuff we learned in chapter 5 about arithmetic and geometric sequences. Arithmetic sequences are sequences where we add or subtract the same number every time to find the next number on our list. Our initial value is our y-intercept, which we commonly refer to as b. Our function type, this is a line, linear equation. All linear equations can be written in the form y equals mx plus b. X and y will stay in our equation. M represents our slope or rate of change. And b represents our y-intercept or starting value. Okay. Geometric sequences are sequences where we multiply or divide by the same number each time. Our initial value is still the y-intercept. In this case, we're going to refer to it as a. Our function type is exponential. Now, the other day in math, we discussed this equation. We figured out what everything was. Well, let's remind you that a represents the y-intercept or the starting value. And b represents our growth, rate of growth, or multiplier. That's the word I want. When we're working with a geometric equation, we will not use division in the general form. We will only use multiplication. Division makes it, this doesn't work out. Whereas if we use multiplication, it always works out very cleanly. So we're always looking for what did I multiply by? What is my multiplier? And that is b in our equation. So this equation that I circled here, y equals a times b raised to the x, is the equation we're going to use to help us today. Let's go ahead and try a couple of examples. All right, so let's first figure out what's going on with example 1. And so when I look at this, I notice that it's growing. If I look at what's happening, I add 10 and then I add 20. And since that's not the same number, this is a different kind of equation. So I'm going to look for something else. And so it's timesing by 2 and then timesing by 2. So that my growth pattern is multiply by 2. And that is our b value for our equation, if you recall, y equals a times b to the x, where b is the multiplier. Okay, what type of function is this? This is a geometric equation function. And we will also say exponential, which is what I expected. They will not all be exponential. Some of them will be arithmetic / linear. What is our initial value? I don't know. Let's go ahead and try to fill out my table so I can figure that out. After 40, I'll have 80 because I times by 2. So what number was there? So I need to think about it. I'm looking for a. So I times a by 2 and got 10. So whatever was there got times by 2 to get 10. So that makes it 5. And so my initial value is 5. So I can use that information to help me write my equation. My equation is y equals 5 times 2b raised to the x. There's my equation. Pretty straightforward. And so now we're going to do the same thing, but we're going to work through example 2. Example 2 is different because the numbers are getting smaller. Let's see what's happening. If I look for what we're doing every time, start by subtracting 60, then we subtract 24. So this is not arithmetic, which means I want to see if it's geometric. So am I timesing by the same number every time? Now I'm timesing by a small number because the numbers are getting smaller, which tells me that the number is between 0 and 1. But I know that I times 100 by something to get 40. So that means that something is 40 divided by 100, or 0.4. I can check that by making sure that 40 times that same number, we'll call it A again, will be 16, making A 16 divided by 40, which is 0.4. So that's wrong. Not really, it's right, it's fine. I just don't want to use A. I want to use B. Because I'm looking for my multiplier. All the math's right. But my growth pattern is B equals 0.4. We're timesing by 0.4 each time. So if I know what I'm timesing by, what did I times? I will times 16 by 0.4, which gives me 6.4. Now tell me what, go ahead and take a minute and figure out what you think that the initial value is. Well, while I'm doing that, I'm going to go ahead and write geometric over here and exponential. Now we just need to figure out what our initial value is. Go ahead and answer that. And it is 250. And we found that by, since we're timesing by 0.4, take 100 and divide it by 0.4, and you get 250. Okay, so my equation is 250 times my B of 0.4, and I raise that to the x power. There's my equation. I should have said y equals at the beginning, but there's my equation. And that is our goal today. Okay, so those are the two examples I have for you, and we have finished our notes. But before we go, let's take a look at our next problem. So this is the first problem on your homework, and I'd like to do it with you. So this is a more complicated problem, and this is the kind of thing you'll see on the quiz tomorrow. In science class, you're studying radioactive isotopes. Your teacher has asked you to complete the following information below if you start with 50 milligrams of uranium. We're talking about the radioactivity and the fact that it will be becoming less radioactive as it sits around. So the number of months that pass are here, and then this is what's happening in the table. Let's go ahead and graph the points on our table. We start with 50. Then we have 1 gives me 40, and 2 gives me 32, which is not really on the graph, but it's halfway between, not quite halfway between 30 and 35. And I have 25.6, so I'll just put that right above 25. That's where I am right now. And it looks kind of like a line. It's not a line, but it does look quite like a line. Okay? So what am I doing? What type of function does this represent? This is geometric, because I'm not subtracting the same number every time. Therefore, it's going to not be arithmetic. It's also going to curve. Okay? What is the pattern? So 50 times B equals 40. What is B? Well, B is going to be 40 divided by 50, or 0.8. I used a calculator to figure that out. So 0.8 is my pattern. I can check that by making sure that the rest of the numbers fit in my pattern. So I'm going to go ahead and just jump here and just check. So if I start with 50 and times by 0.8, I get 40. Then if I do that again, I get 32, and then 20. Okay, so it looks like I'm good. To figure out what goes in the next blank, 20.48. Which will allow me to finish off here just above 20. And I could fill out the rest of this if I wanted to, but basically it's going down. And it will reach a point where it can't actually get less than. I don't know where that is, but it should tail off. It probably shouldn't have curved it quite so soon, but it's going to do something like that. What is the initial value? 50. They gave it to me. I found my pattern, so now I can write my equation. Y equals 50, parentheses, 0.8, raised to the x power. All done. And that's it. Hope you have a great day. I will see you guys soon.